Everyone. Welcome to Hancock's webinar about the latest energy modeling in the DOE approval process for the HEAT app. And I have Art Willcox with me today. Many of you know Art. I can see that everybody's attending. Probably already knows Art. Art, you want to say hello to everybody?
Hi. We've made a few changes recently at DOE's instructions, so that's what we hope to go through today. It shouldn't be overly burdensome.
It looks like we still have a bunch of people coming in. So I have already started recording the webinar. If you signed up for it, that's the email list I use. So as long as somebody signed up for it, they'll get the recorded webinar. So while people are still signing in, I just wanted to talk about the newest energy model and the approval process in general. Art, I think you're the best person to talk about this. Art is working with many of you all out there right now. So he's working with Virginia, Rhode Island, Maine, Pennsylvania, many of the states that use Hancock for energy modeling. And he's working to get them DOE approved. A number of them have been DOE approved already. And Art, I just thought, could you give everybody an overview? If they don't have DOE approval for HEAT, how do they go about getting it? What's the timeline like? Generally, what's the process?
Yeah, once there's an intent to use a tool in whoever you're working with at DOE, recognizes that and gives you the process. From my perspective, it's a bit of a fractured process in that we no longer talk directly to SMS. What we want to do for anybody going forward is to make sure that being the reality today is that each communication from me to you, from you to DOE, from DOE to SMS, and back we go, moves through quickly. And there's not a lot of back and forth over any one particular issue. And fortunately or unfortunately, Virginia was kind of it was the first state to go through this. And I think we have a pretty good process down. So a request is made to DOE. They then probably communicate with SMS and Caleb, and he may go directly to you and tell you he would like the model jobs entered. Now, so far, for the states that Danielle has referenced, there are four sample jobs. Now, these are not to be confused with your auditor entered job sets to demonstrate that they know how to use the tool. These four sample jobs are to demonstrate that the tool that's on your staging site is the site that DOE first approved in the case of Virginia. So I'm very familiar with the four jobs. They're the same exact jobs so far for every state, to single family, to mobile home. They're entered, and the best thing for us to do is once you've entered them, or any time in the process of entering them, communicate with me directly with any questions, and then at least a final review before they're submitted to DOE for SMS's review. I have a very good idea of what to expect. Obviously, the only variances would be the heating, cooling degree, bin degree hours that are used. So it's very easy for me to make sure, yeah, this is what they're expecting on that job being entered. Doesn't take much time at all. I just basically compare ES reports with you, look at the jobs on your staging sites. And once they're sent off, we don't want any mistakes on them. Let them go to DOE and Caleb sees them. And ideally, he says, yes, this is exactly the same auditing tool that I've approved for Rhode Island and Virginia. And at that point, you have the remainder of the process, which is training the auditors on any changes that we've done if they've used the tool in the past, and then submitting your auditor test jobs to DOE. That really doesn't require me, but I'm happy to review them with you if you have any questions once they've been entered. And they get sent off, and you will hear back most likely directly from DOE once Caleb has checked everything over. So that's really all it's about. I would suggest that before you enter those sample jobs, maybe just do a quick, even after going through this, just a quick review of the somewhat adjusted functionalities. Most of them are what I would call trivial in 99 out of 100 cases. They're easy. We made them as user-friendly as possible. And probably the only significant area, and it actually makes it just as easy or easier than before, is around the duct distribution system efficiency calculation.
Okay, all right, let's keep going because we're going to show that in detail.
Go ahead.
Okay.
That was all.
So in general, the DOE approval process for us is reach out to DOE. DOE gives you 4 example house situations. You enter them in our system with the help of Art, and then you submit your DOE approval with that and your other sample jobs that you already have prepared. What is that, the 10 sample audits or something from your network, Art?
Yeah, the only other thing, Danielle, remember, they'll be probably submitting also our user manual that's been updated for these minor changes. And we, of course, have a generic Word document that you can cut and paste from.
Okay. So I have my iPad on one screen here, and then I have a list of some of the new features. I thought we would go through an audit from scratch. We'll try to move quickly so we don't get, just so you're not looking at me enter a record from start to finish the whole time. So what I did before the webinar is I thought whatever you see on this, you can see Art, you can see my heat app right now. Is that right?
I believe I do. Yeah, I do.
Okay. This is on the mobile heat app, or it's also on WAP Online. So you can decide where you do this data entry as usual. We do recommend if you do it on the heat app, it is much quicker as far as the performance of the software. This is a very quick process of data entry. So I have downloaded a single family gas audit. And to give you a little preview of this, if I tap energy consumption here, it just has a hot water heater and a furnace that is gas powered, and then its base load and AC is the electric. And I think it looks like I have heating at electric, but I can take that off. Okay. So nothing changes as far as the beginning of the audit. Is that right, Art? As far as just entering your house
Yes,
dimension?
that's correct. That's correct.
Okay. So it shows you the required fields to enter first. I'm from Maryland. I don't know if you all know that, so we'll pretend that this audit, the single family house, is in Maryland. And then you enter basic house dimensions. We'll do, all right, what do you want to do, 20 by?
Yeah, 30 by 40. Do a 30 by 40. Very simple, single story.
Rancher. with
Yeah.
8-foot ceilings. Okay, so nothing has changed there. As we move beyond the audit here, the rest of the information might not be energy modeling here, but it will contribute to our embedded new ASHRAE calculator. So we will show that too. So for example, a dwelling unit configuration. So these can contribute to the ASHRAE 62.2/2016 calculator that we do have built into heat now. Number of rooms here. So, you know, if you have a number of bedrooms, you can check the year built. And that's it for the beginning of the data entry. Now, you can decide whether you want to do the mechanical system, like the heating and cooling first, or you want to start at the shell. Art, where do you want to start?
Let's start with the heating cooling.
Okay, and you'll see that the menu hasn't changed. However, we have added this ASHRAE ventilation, and you're going to really like this. This we designed to more closely mirror the RED calculator as far as the user interface goes, but you just don't have to do all the data entry from scratch. If you do the data entry as part of the audit, it carries over to that calculator. Okay, so Art, here we have a forced hot air furnace.
Sure, that's best. Pick a forced hot air. Yeah.
Okay. And what is the size here?
Make it 70,000.
70. Okay, and it defaults to an efficiency of 80%, but you can edit that if you test the furnace.
Make it 70,000.
Oops, yep, okay. And then given the system age.
Now there's a something around this issue. System age no longer affects combustion systems. It affects closed systems, central air source heat pumps, which is just the reverse of how it functioned previously. So one of the DOE's requirements is to just flip that. The algorithm's still the same. You put in the years and it declines the efficiency based on the same algorithm. It's just used for combustion, which it wasn't before, and it's no longer used for closed. I mean, it's used for closed system and not for combustion. So.
Okay. So you can do a measure here. If you were to replace it, should we do a replacement, Art, or you want to?
Yeah, that's fine. Do market is removed, exactly. Okay. Nothing's changed there.
I think I have, yeah. I think I have to. I said I wasn't going to remove it, so I have to do that first.
Oh, if you weren't, it's
no, it's fine.
Not a big deal.
Okay, and if you replace it, you just add a new system here, and you make sure to check new heating system. And you'll see the energy savings come up here. Okay. Shall we move to a central AC system?
Yeah, you can. Sure.
Okay. You do have the ability in your state, I don't know if any of you all use this, to ask questions in each energy audit section. So if you use this one can be configured and the auditor can just go through and ask questions. Okay. So now we're going to move to cooling. And here I'm going to change this to cooling. So if you were doing a heat pump instead, you would do heating and cooling there. Okay. Any comments about the central AC, Art?
No, it's also.
Same output?
Oh, the cooling output,
Yes.
those do change. But that's part of a measure, so.
Okay. Okay, are we doing anything to the AC?
No, let that go. We
Okay.
don't have to.
Okay, so now we're gonna go back and do the distribution system, right?
Yes, that's one of the things that's changed the most.
Okay.
And it's around ducts, of course. Very quickly to describe it, the BPI matrix approach is no longer allowed. So that's removed. You have three options for determining duct efficiency, and it's going to be the blower door method, the blower door subtraction method, however you call it, a duct blaster, or pressure pans. Most states use pressure pans in all cases. We have one state that in certain instances will use a duct blaster on the central return.
Okay, and which one would you like to do?
Do the pressure pan, that's most commonly used. It may be used commonly already.
Okay.
There have been a few changes though, so go that way.
All right, and this one, the run sections first, or the detailed testing?
I would put, go ahead and put the run in. Runs, one return, one supply.
Okay. Saying I have like red, I don't see red. Oh, here. Okay, go ahead. You can tell me what to type.
Oh, put in 80 feet. And just
This is new, right?
12 by 6, whichever one, doesn't matter. Diameter skip, you're all set there. Our value is if it's insulated, leave it uninsulated. And then select where it's located.
Okay, so you would want to use diameter if the duct work was a round shape, right?
Yes, that's correct.
Okay.
And then you want to enter a return as well.
And these are metal ducts, most likely.
Yeah, mostly.
Okay. Yeah, I think I forgot to save that. Okay. And what would the return information be?
You could have a return of, let's say, 10 feet, and maybe it's going to be a foot and a half by a foot. I don't know, just something like that, 12 by 18 or something.
Okay. Okay. What else is new here?
Well, part of what's new with the calculations, you have to enter the detailed testing values. All right.
Go ahead.
You've already got, you only need one supply and one return. So go back to zonal distribution.
Is my screen slow maybe?
Oh, I don't know.
What do you?
You entered the return in the supply, right?
Yeah.
Okay, then go back to the zonal distribution.
I'm in zonal distribution. Do I have to add a detailed testing? I am in detailed testing.
Yeah, detailed testing I want to enter.
Yep, that's where I am.
Okay. Oh, you are there. Okay, so that's why it's red.
Uh-huh.
Just pick anything, bedroom. We're just going to enter one. Obviously, pressure pans, people are going to enter most likely multiples for pressure pans. But you just, as before, if you've used it, you just put in Pascal and post. So put it in as a 0.5 and a 0.1. You might have smaller ones, larger one, depends on how many you're entering in the condition of it. And the nets, well, in square inches, put 144, just for the heck of it. And then just you put in as many as you're testing. Obviously, it sums it up, and go from there. And just do the same for the return.
Okay. So add it. So this needs to be empty, you mean? And then you add a second one for the return.
Well, you did the supply, right? Yeah, do another one for the return. And that can be anywhere.
Okay.
Yeah. And it would be a larger number, maybe, but it doesn't matter. That's fine. Go ahead.
Go ahead. You can just say quickly. Go
All
ahead.
right, just put a 1 and post will be 0.5. The numbers are just for test purposes.
Okay. So if
Once
we
you
want
get that, go
to
ahead.
do we wanna enter a measure?
Yeah, I would enter, just put in some insulation. We already put in a post for the pressure pan values. If there's,
Okay.
you gotta, yeah, that's good.
Okay. And I get the total length of the duct must be greater than or equal to the total quantity.
Oh, yeah, did you put in
So I
different
did not, yeah.
values for the measure from the,
I put in less that I was able to insulate. So I thought I did. Oh,
what was,
maybe it's the return that it's catching. Okay, go ahead.
okay, so if you've got that in there, you should be all set with the heating stuff. Now, I just wanted to make a note that if you use, nobody does anymore, but if anyone chooses to use a blower door subtraction measure, it will guide you to make sure you enter a couple of records at the air infiltration screen. Clearly, to do the subtraction, you've got to have at least 4 records, pre and a post, open and closed registers. But I don't know anyone who is using that. The duct blaster is entered virtually the same as pressure pan, but your numbers are going to be quite different. Okay, so then we can go on to attic, I guess. What we're going to find routinely across the architectural surfaces, well, except for basements, is we're going to have some adjustment factors to those architectural sections. And we'll find them here. So you're basically entering the data the same way. But we have hopefully a very simple way of adding buffered surfaces and valuing their change in ambient temperature. And then we also have here, so yeah, once you get all that basic stuff in. So framing percent, notice that that's defaulted at 15, which is common, but you can put in anything else you might have in that particular structure. So you can change the percent. Also, you'll notice that there's a ventilated ceiling checkbox. That's intended to be used for eliminating the opaque surface solar gain through a roof if the attic is ventilated. I think people can make an argument for, well, some may be passively vented, but they're stable and they're only a hobbit could stand up there and it still gets very hot. But that's on your end for auditor training. But if you check that box, there will be no solar gain through that opaque roof. Also buffered by. There are three options. Attics, they're not obviously common, but you can on a sidewall in an unfinished attic. We made it as simple as possible. If you have a buffered space, let's say a garage against a basement wall, and that garage is unfinished. Unfinished means it's framed and that's it. And that will reduce the outside ambient temperature by about 5%. If you select, there should be three choices there. So now insulated space means that it's framed off and there is insulation in the bays. Unfinished space means it's got sheetrock on it as well, so it's totally finished off. And you have these slight increments in reduced ambient temperature on the other side of that buffered. So you get less and less savings as you move up from unfinished to insulated to finished.
Great. And do you want to explain this new checkbox for removing existing?
Oh, remove existing, it simply means that maybe it's vermiculite or it's something else that has insulating value, but it needs to be removed for a range of possible reasons. When you do that, that will automatically decline your value. So say there's an R7 in there and you're going to remove it and put in an R30. You only get a benefit for the difference between R7 and R30, not R0 and R30, because that home was performing with that health and safety issue, but it was performing as an R7. So remove existing reduces the cost effectiveness of that measure. But it should make it more accurate in terms of matching actual use, if in fact you have decent actual usage.
Okay.
That's it.
So should we add some insulation?
Sure, just pop something in there.
Okay.
All right, let's hit the walls, whatever's next on the list. So as she's entering them, we have the framing percent again, which is going to be editable. You have a buffered by as well. You have a shading. You don't have that ventilated ceiling clearly, but you do have a shading, which allows you to put a percent there. And what that does is reduces a solar gain through that opaque surface by a certain percent. Say you got two triple deckers up against each other and one of the walls gets almost no sun. You can put in whatever percent solar gain reduction you want there. It's obviously a bit of a guess. You may have trees there and you put it in at 50% and it looks good against actual usage, and maybe a year from now you're going to save less simply because they cut the trees down or they died or whatever. So again, not huge issues. A number of them are around the value of other uninsulated sections or increasing or reducing solar gain, or the impact of the framing that's in the attic as an R value.
Okay, so I'm going to add the east and the west wall. And you can see each wall is added down here. So I have a south. Might have two souths. Yeah. There we go. I have 4 walls.
Okay, now let's just put in a fairly, maybe a crawl space type of setup condition.
Okay.
Going forward, as things are configured, I believe, and you may want to check, but I believe DOE's desire is not to use what historically have been allowed for basements, which we call simple sections, except for slabs, obviously, or insulated slabs. You can enter now multiple complex basement sections. We were allowed to do that recently, and so as we go forward into the new approval and setting up the live sites, we should probably work with you to make sure that all unneeded or inappropriate simple sections like conditioned basement, they should always be checked off as conditioned basement complex. Or we can relabel them any way you want. We can get rid of the complex if we're getting rid of those older, simpler sections. So we want to configure the naming convention that works best for you and your staff. But the objective, primary objective, is to remove all simple sections because they're not needed except for slabs.
Okay, so if I am defining in this is a crawl space, the basement area above me, that would be 140, the area of the ceiling.
Well, you're doing the ceiling, you would have, so the width and the length, you'd be, no, you wouldn't put it in there. You've got a house that was what, 30 by 40?
Yeah.
So this is the ceiling, you'd put 30 by 40. Vertical surfaces that you're measuring, such as sills or above grade walls and such, then yeah, you sum it up to 140 times whatever the height of it would be.
And we're going to see that new remove existing option again.
Yes, that's true. And the buffered by is rare, obviously. That would be in a raised ranch, maybe on a surface that on a hill, and half of the wall is above grade or whatever. And yes, and there's something buffering it. It's rarely used.
And what about this heating system, waste heat?
Heating system waste heat. This is identifying any basement section within which there is a heating system, and waste heat is to some degree expelled into that area. It slightly moderates the temperature of that basement section. It makes it slightly warmer.
Okay. And when you're doing this complex basement, now we'll default the section type to whatever you selected before.
Yeah, it's a little faster entry now, yeah.
Mm-hmm. And we actually populate a new section of the basement to just tell you what entry is next. So what are above grade basement wall?
You can make it 140 by 3.
Okay. So we have the sill left.
Mm-hmm. Same thing, 140 by 1.
All right. And no thermal boundary? Or, yeah, foundation wall. Okay.
Well, the thermal boundary, you're going to want the thermal boundary to be the basement ceiling. Yeah, the
Okay.
floor. Yep.
Okay. So what we do is we automatically add those components for you, it looks like, in this new release.
What happens is once you pick the initial complex basement section, it generates the linked records and you edit the values. You don't have to keep going back and saying vented crawl space. It pops them up sequentially.
Oh, nice.
Well,
Okay, so we're good here. We have a sill above grade and a
yeah,
basement ceiling.
we
Okay.
have the basement floor. They have one for the
I don't think so.
crawl space. Good. Okay, that's fine.
Let me just make sure. Yeah, I think you did it all.
Okay, if you did it all.
Yep. Okay. Do we want to do air infiltration or you want to add some windows first?
Yeah, why don't you grab some windows and throw them in?
Okay.
Whatever you want to pick.
All right, we'll just do one door and some windows.
Sure, that's fine.
We'll do.
It's just for demonstration. Also, going forward, if you want, we know on existing windows, a lot of people don't have good default values for existing window solar heat gain coefficients, but they can now be entered in a admin site, and then they will always default to it. Say you have a single pane clear glass, it would pop up with a 0.65 or something. You could edit it, of course, but a lot of people don't have that information. They're not carrying a piece of laminated whatever around with them with their local values. I can do that for you on the admin site, and then occasionally if someone wants to edit it, they can.
Okay. So nothing has changed really with our window
No.
calculations.
No.
Okay. So I'm going to go put these windows, I'm going to put half of them on one side of the house. And I'll put the other half on the other side of the house. Okay. Blower door test?
Yeah. Mm-hmm.
Go ahead, Art. You can talk me through that.
Sure.
This is new, right?
Just open registers. We're only doing open registers. We're not doing well, yeah, depressurized. And yeah, 50 is good. Put in 15, yeah, 3,000. What the heck? Oh boy, that's really leaky. Okay, good enough.
And a target?
Yeah, add target. That's good enough. Obviously, you would have a post when you were reporting it out,
Mm-hmm.
but this will give you results.
Okay. Anything else change about base load?
No, base loads fine as everything else is the same.
Okay. And do you want to just walk through this quickly, this ASHRAE calculator?
Oh, the ASHRAE calculator, we tried to make it similar to other things, including RED, to make it, we've worked with a couple of states. Yeah, if you have any comments or questions about it, let me know, but the calculations, we've matched them up with many cases, and they produce reliable results. So you can simply use this if you want. If you're still more comfortable using RED, go right ahead. You can enter it in here separately if you want to keep it in the system as a record. But entering it directly here, most of it populates as a result of stuff you entered elsewhere.
Yeah, in this example, I really
quick.
just had to confirm the weather station. Everything
Mhm.
else, like the floor area, the occupants,
Mhm.
the maximum floor numbers, and the CFM testing, that all populated directly.
Right there, that's what made it convenient. Basically, a couple of states asked us to do that, so we did.
Okay. Now, I don't know if I'm going to get it. I still get this message. The length of the duct run sections has to be greater than the quantity.
Well, let's just check it out. Maybe the measure is longer than the
Okay.
or the square footage total.
Because I only put like 10 linear feet in here.
Okay, then how many did you put in for was that for the measure?
For the
or
measure.
The duct? You
The square
have
footage
length
total.
10.
Mm-hmm.
That's the return, and you put the 50 square feet, supplies 240. Where did you put the measure?
We can just see if the energy savings runs. I might just delete that measure for now.
Yeah, go ahead. I will look at it more closely. We haven't had any issue with that.
Okay, I have a window that's not assigned.
Oh, okay.
There we go. Okay. So I gotta bring up, let's look at the energy savings here. And why don't you talk us through, Art, that single family house audit energy savings that DOE gives, that example.
Okay. Okay.
Now I'm gonna zoom in just so you can see this better. Go ahead.
Okay. Okay. So of course, everything in red up above was meant to meet the requirement. It may already be in there for you. That if you're more than 20% off between your actual and model values, then it just warns you up there, and you may want to rethink something in the audit or double check the actual, or just put a comment saying we only had actual usage for 4 months or something in a rental property, what have you. So we get the overall job SIR up there, some basic information, but the key is a little bit lower. You have system design and capacity information that we've always had. We made some slight adjustments here to labels and got some calculations more accurate, but the listed values are just generally informational and based on information entered. So let's scroll down a little bit further. The key is right here, energy saving measures. Let me move something on my screen. So can you just slide over a little bit to the right? Yeah. So you got all the SIRs listed, and this is what we're going to want to look at to make sure we're getting roughly the same kind of savings in SIR, adjusted for obvious degree day differences. Some of the big things that can affect the SIRs are obviously measure costs and degree days, but it's also SIRs are going to be affected, particularly around if you're putting in a heat pump. In the case, if you're putting in real numbers for a heat pump and you're changing from gas to electric, that heat pump's going to have to be pretty darn cheap to pass, because most likely in your fuel vendor records, you're going to have natural gas, which is one of the ones they'll give you, where you put in a heat pump. You're going from gas to electric. I don't have to tell anybody here that per MMBTU, that is dramatically higher for electric. So if you get an SIR of 0.3 for changing, you'd be lucky. It'll pass on electric to electric, but depending on what data you have for the fuel vendor for this record, for electric and gas, it will tell you. So for example, in Virginia, gas, they were both close. I think they were around a little over $1 per CCF. But on the electric, Virginia had 11 cents, and Rhode Island in that particular case had about 19, so double. So that SIR went from a 0.3 in Virginia down to an invisible value, about a 0.002 in Rhode Island. But we adjusted things a little bit and to show DOE that this was just a difference in state valuing the cost of electricity relative to gas and everything. We changed them to match, and bingo. So this is one of the things I'll check with you. But this is pretty straightforward, expected numbers. Nothing new for you here. We've tried to put in some totals near the bottom. So we have the architectural totals, we have the consumption totals, which is basically simply adding the efficiency of the heating system to the section pre and post usage. Obviously, if it's a heat pump, your architectural is going to be much higher than your consumption because you're running at about 200 to 300% efficiency. Whereas in gas or oil, it's the opposite. Consumption is higher, not lower than architectural, even if you have a 90% system. So if we scroll down, just have the usual information we've always had. The system fuel is where you can also check the difference, and I think everybody knows this, between modeled and actual. So in this particular case, it's modeling in the precondition at 104 MMBTU, very sensible number. The actual reported pre-MMBTU is 20.6. It's about 4 times. No, 5. Clearly, that actual is going to be wrong for a home of that size. But if that's all you have and you want to put something in there, then you have to add a comment. We're not going to block people from moving that way.
This is also a useful way to see if you just wanted to do a base load audit, you could do this.
Sure. Yep. Any fuel source Yeah, any fuel source that's used is going to have a record there. DHW, cooling, base load, and heating. Okay, so if you can scroll down a little bit further, the consumption and the electric, that's architectural loads. They're all individual loads. I always use that. If something's weird and doesn't look right on the ES page or what have you for that house, I tend to go to the architectural loads. It's a quick way of saying, whoa, wait a minute, this number is way too low or way too high. Do I have a decimal point issue somewhere, what have you? So I think for most auditors that are involved in this, it's a good area to look at the actual section loads for the attic, each basement section, doors, windows, what have you, pre and post heating and cooling.
Okay.
And really that's
So
about all. Yeah.
Yeah. So like just to give a high level review, if we wanted to just look at the changes, you can decide whether to use the mobile app or not. So we showed some of it on the online system. We showed some of it on the mobile app. And in the shell, in the envelope section, you're going to see a couple uniform changes across each envelope section. You'll see the ability to account for when you're removing the existing insulation from the space. You'll see the ability to define a buffered by. On the vertical areas, like attic, you'll see the ability to account for a ventilated ceiling. So those three changes are on every section of the envelope. In air infiltration, we just kind of streamline this so you're entering target and pre as a test result. And you can set up open or closed registers. We tried to streamline the audit by adding the ASHRAE calculator in to be more user-friendly, to be more reflective of what you're used to with the red calculator. Art mentioned the biggest change, it really lives in zonal distribution because DOE no longer supports a simplified BPI level assessment of distribution. The state should do pressure pan or blower door or duct blaster method. You can set up our online system to decide which of these options to show, so you can steer the audit in that way. So you have your duct detail testing for pressure pan. You signify if it's metal duct work and what distribution, heating and cooling systems this distribution system is used by. So those are the changes. The final energy savings level got a whole lot more comprehensive in that DOE required that we compare it to the actual reported. So actual in Hancock means what did you enter for the billing data and what is the difference of that? And like Art said, if it's greater than 20%, the system's going to tell you. It's not going to block you, but it's going to tell you, so you can go and adjust or comment why what you're entering the actual is so far off from the model. So I think we did answer a few questions as this went on in the question box, but it looks like somebody has their hand up. Michael, was that on purpose? Did you want me to try to unmute you? Do you have a question for Art? It looks like you meant, yeah, go ahead.
I had a question. Art was going over the closed systems and stuff like that. And I just missed what he said, but I saw when you guys went back on the notes what it was. So that's all I had. I'm good.
For the blower door, you mean? Or the district, what are we talking about? Oh, for the heating and cooling.
Yeah, the heating and cooling. He just, I didn't hear what he said. And I wasn't sure. And then, we went back and it came up on the, I guess, the handout or whatever page, and I understood that. So everything's good to go.
I'll send out these notes. This is like a very in-depth explanation. So I can send out these notes as part of the follow-up video to this.
That'll be
so
good.
You guys can review. And if you have any questions, I'll give you all Art's email, and you guys can set up a conversation with Art.
Sure, anytime.
But Art really is close to this process. So if you're a state in the getting DOE approval for heat, he's there to really look at your jobs and assist you with the data entry and the training. Can't stop coughing. Okay, so my last comment is we have a couple webinars coming up in the next few months, and I will send out an invite to that. One of them you might be interested in. We are working on our new app. We're working on bringing this model into our new app, and the great thing about the new app is it's not like it's really flexible and easier to use than the heat app. So we are working in moving this engine to our new app. So I will show that in the next couple of months. And then next month we'll have a webinar on single family house, how to model that on deemed savings in our new app. So just keep a lookout if you're interested on what's coming in the future. It's not going to be immediate because it's a process to get you all that use our heat app now. It's a process to get your back-end systems on our newer system. But just keep a lookout. We'll be running these webinars like once every 3 weeks, and you're all on the invite, the distribution list. Okay, I'll send out the video and these notes probably either tomorrow morning or in a couple of hours. Okay, anything else, Art? For
No,
anybody else?
thanks, Danielle.
Okay, bye everybody. Have great Thursdays.
Thank you.
Bye. Bye.
Bye.